everyone, this is Manav again with a new topic, energy, work and also about power. We are going to learn about all these terms in this video. So let's begin with a daily life example of work. As we all know that we use this we use this term in our daily life mainly while when we are doing our homework or when we have completed our homework. We say that, oh, I have done a lot of work. That work term is also related to our physics term. Or in the physics, work mean any other thing. So, I would like to say that in the physics, work mean that when the force is applied on an object, and then it displays from its initial point. Let's take example of this chair. So, first this chair was here, and I take it. How I take it? In my hand with the help of some Newton X force, X Newton, and I take it, I make it there. So is there any work that I have done here according to physics, according to the laws of physics? Yes. Why? Because first, when our object chair was at the initial point, at the rest, I take it with the help of force, and I take it, I place it. There is force. There is any that we can say work done? No, there is no work done. I will tell you about this. But before understanding, let's take some example of our work done in physics. So we can take example of chair again. This is chair. I think you cannot, the chair is not visible. So this is chair. And first this is here. And then I have not taken it. I have not taken it in my hands. I have just push it, and when I push it, it displays 10 centimeters, it displays 2 meter, it displays X meter. So there is also the displacement, and without force I cannot make it displace. So when the force is applied on an object and it displaces from that its initial point, at that time we say that there is work done. Not in a simple or in a daily life, but in the language of physics. I'm right. What is the formula of physics? What is the formula of work? Because without formula you cannot solve the numericals. I'm right. So the formula for the work is force multiplied by the product of force and the displacement is equal to our work done. Now there are some terms and conditions. About that there will be work done, there will be work not done, at which condition, at which time it is perpendicular, the gravity is perpendicular. And in the beginning, in the beginning of the video, I have made example that I have taken that chair and placed. I said that there is no work done. There is zero. If I used to go with the physics, I'm right. Zero work is done. Why? I'll tell you. So I think you can understand the formula. That the work is the product of our force and our displacement. If it displaces 2 meters, so 2 meters multiplied by 5 Newton. If I used 5 Newton force, so 5 multiplied. Now, in the physics, One thing also matters. SI unit. SI unit matters. At this time, about the SI unit, I think SI unit of the work done will be Newton meter. Why I am saying that Newton meter? So please remember, when you don't know the SI unit of a particular thing, of energy, of our work, of our power, when you don't know about that, when you don't know, at that time you can find the SI unit with the help of the terms that are given. Here there is our force and our displacement. Our displacement means the length can be classified as meter, and our force, the SI unit of force is Newton. So I can say that Newton meter, I have taken the Newton from our force and the meter from our displacement. So it becomes Newton meter. Easy. But if you cannot remember this, or if you wanna learn about the particular specific SI unit of the work, so that is joule, denoted by J. Now let's take some example. I am reading. There is work done. And now that the example that I will take will always relate to our topic, mean to the physics, not to our daily life, not to the English word work, to the physics term. I am reading. Is there is any work done? No. How no? Why not? Work is not done because I am reading. I am speaking. There is a force. I can say that. But there is any displacement. I am just reading. I am just reading the words. I am just reading the words of a particular language. I am not displacing. If you take the example of taking the book, there was a table here. There was a table here. The distance is 2 meters. I have taken the book. There was a slab between them. Push it. So there was a displacement also, and a force was also applied. Now this is work. There is work done. Yes, exactly, work done. But in a reading, work was not done. I'm right. Work was not done. No. Work was not done. Now, a trolley. I have a trolley. I was shopping in a market, and there was a circular path where you'll have to go. Then you will enter into the supermarket. So, I have taken that trolley and circular. The round that you'll have to take is 2. I have taken it. After that, at that time, there was a force, there was a displacement. But now I am saying there was no work done. Work was none. Work was none at this example. How? This is a very important condition. Please remember this. A very important condition, that if the object is moved up and come to its initial position, like example of that I have given. So at that time, the work is 0, because it comes to its initial point, into its that point. So work is 0, work is nota, work is none. I'm right. Second thing, force must be applied. Third thing, our object must be displaced from its initial point. If I am pushing the ball, the ball will never displace from its rest position. It will never. So if it not displaced with no displaced. So how the work done? We also need the displacement in our formula and also the force. So our work is not completed. Now, a very important example that is like a condition. That condition is I have this chair, or let's say I have wait a second. I have this bucket. I have this bucket. So I have taken this bucket from here and set it here and make it two place there. Now the work was done against gravity. Gravity was perpendicular. Gravity because the surface is down. So our sorry, our force will be perpendicular. There will be a 90-degree angle formation. So there will be no work done. This is what that you should remember. Okay. So now let's begin. Let's move on to the energy. If I will continues to speak, I'm continuously speaking for 2 hours. After some time, I will do like this. So I think you have understood. I'm right. I will going to. There will be my eyes will be like this. I cannot do work. I cannot, if I am taking some bricks, I am pushing them and taking for 3 hours. After some time, I will feel that I am too sleepy. I need a little break. I need a little rest. At that time, why I cannot do the work? This is due to of the energy. Now you will say, what do you mean by energy? So energy is the ability to do work. If I have 10 joule energy, it's a unit of energy is joule also, so please remember this. If it is 10 joule, so I can do work. If I have 0, energy is my 0, so I cannot do any work. This is what that you should remember. I'm right. There are 2 types of energy. Potential energy and kinetic energy. If I am moving or I am making an object to move by pushing it or pulling it, if there is a displacement, work is done. There is force also applied, work is exactly done. But the energy that is created due to the action, due to the motion is known as kinetic energy. Please remember the energy that is created, that is made by the motion of the movement of the object. By the motion of the movement of the object is known as kinetic energy. I'm right. Now let's move on to the potential energy. I would like to say that potential energy is also stated as, or we can say another name of the potential energy is stored energy, because it is stored in an object. Our potential energy is the energy that is stored against the gravity. That is stored against the gravity. And that is stored at a height. It is made by the height and also by compressing. I'm right, by compressing. So you can say gravitational energy, potential energy, that is the energy that is stored against the gravity. So the formula for both kinetic and our potential is for the kinetic, please remember square of velocity, mass multiplied by square of velocity, half of mass multiplied by square of velocity. 1/2 multiplied by mass multiplied by square of velocity. Acceleration we can say. So, and of the kinetic of the potential energy, it is stated as mass multiplied by gravity multiplied by height. Gravity can be taken as 9.8 or mainly people take 10. You can take either 9.8 or 10. Alright, so why I have used gravity? Because the potential energy is against the gravity. Potential energy is against the gravity. Please remember this. Right? And don't take weight here. Or you can take weight multiplied by height, because m multiplied by g is equal to our weight. So we can take weight also, but you cannot take weight multiplied by gravity multiplied by g, actually, because m multiplied by g is our weight. So weight if you have taken, so don't take the gravity again or a mass again. Alright, so I hope you have understood our today's topic at no. Sorry, it's not time to goodbye, because I have not make you understand about the power. So what do you mean by power? Power is the work done by per unit time. It is not exactly as energy. Energy is the ability, capacity to do work. But our work is power is what? The work that is done by per unit time in 2 seconds, in 3 seconds, 3, for 3, 6, 9, like this. The formula for the power is equal to work done divided by time taken. If your work is more than your time is shorter, so your power will be more, because you are doing much more time, much more work in lesser and shorter time. Right. And that's the unit of this our power is watt. So I hope you understand our today's topic. Now our topic is completed.